we're going to be working in lesson 3.1 for more than today, but here's our learning goal for today. And this is actually what you were just doing. I can match simple graphs with situations. So you had 5 graphs, 5 situations, you had to match them up and decide which ones went together. And then what we're going to do next, after we're done with this front side, and why we had you open your book, is because then we're going to graph a relationship. We're going to show what when we're comparing a couple of things, what would that look like on a graph? Okay, just a sketch of a graph. So here you were supposed to be, we got the motion of 5 cars on a highway, that was the situation, the 5 situations, and you were to match them with the graph that represents it best. So, the car's speed remains constant. Which graph do you think that one goes with and why?
Graph C.
Okay, graph C. What's the reason for it being C? Okay, so when we are looking at this one right here, graph C, as you move across the graph, time is moving along, and the speed, as you go up on the graph, the speed is doing what? Increasing. Well, it looks like it started at some amount. Do we have any idea what the speed was that they were driving at? No, but that does not matter. What does this tell us when it just goes straight across?
It's staying at a steady pace.
Yeah, so the time is going on because it's moving to the right, but the speed is not increasing, so that is a good choice. This car's speed remains constant. Okay? The car's speed increases slowly but steadily. Both of those words are important. The car's speed increases slowly but steadily. D? Okay, how many of you want to agree with D? There are lots of agreeers with D. Okay, what's the reason? Why is it D? So we want D, you're saying. We're going to make this one.
Going up slowly.
Okay, so it's not rising at a very fast pace, is it? It looks like it's increasing pretty slowly. Okay, and what is describing the word steadily then in that graph? It's hard to describe that part, isn't it? If it's going steadily, what's it doing? Well, slowly would be the creeping. What's the steadily?
It's moving up
It's moving up
at a steady rate.
at a steady rate. So how does the graph show that it's a steady rate? Aurora? Yeah, it's kind of like there's no change in how the line goes. It doesn't start zigzagging or taking a different direction or a sharp incline. As you go across the graph, it seems to be going up and over kind of at the same pace. It just keeps climbing steadily. There's no break in that line. It's just a nice straight line. So the slowly is the fact that it's pretty, it looks like it's going up slowly. It's not very steep. It's pretty flat. And increase, of course, it's going up from left to right and steadily. So I think we could agree with that one. Okay, how about 3? The car's speed increases sharply. The car's speed increases sharply. A? Okay, everybody pretty much in agreement there? Okay, why? Why is it A then?
Because it says increases sharply, so most likely a sharp incline, so you're going up in speed.
So it's going up a lot faster than it's doing what?
It's going forward.
Then it's going over. So not very much time is going by, but the speed is going up pretty fast. So it's increasing sharply. It's showing that the speed is rising when it's going at that sharp of a rate in such a short amount of time. It would show that it is increasing sharply. Okay? What else do you think we could say? What other word do you think we could add to that they did not have? It's increasing sharply and
Fast.
it was steadily. And sharply kind of talks about the speed of it. It's going up fast. Sharp kind of like saying the word fast. But steadily, isn't this one steadily also? Are there any, zigzags in that line that it's changing speed? It's just kind of going up steadily. Okay, how about the car's speed decreases gradually? It's going to be B. Okay, have I used every color? Not quite yet. Okay, so this one's B. Decreasing, what shows it's decreasing? The speed is decreasing, it's going down. The speed starts out here, and as you go across the graph, as time goes on, the speed is going down, so it's decreasing. And gradually, what indicates gradually?
Going down at a steady pace.
It's not going down very
Fast.
sharply, yeah, not very fast. It's got a pretty flat, it almost looks a little bit like C, but it is decreasing. And then that only leaves 5 to go with graph E, but does it match? The car's speed decreases suddenly. Can we agree with that? Okay, so we're going to say our last one then does go with graph E. Okay, well then let's go down here to our think and discuss. Explain how the graph for the car in problem 2. What's happening in problem 2? What's that situation?
Car speed increases slowly.
Slowly, but steadily? Slowly and steadily? The car's speed increases slowly and steadily. It says, how would it be different if the car started from a complete stop? So in other words, they're saying, how would the graph change? How would we draw it? They're still going to go slowly and steadily, but they are going to start from a complete stop. What do you think, Jossie? Did you have a hand up?
Well, I put the speed would increase faster, but
No, the only thing that's changing is it says if it started from a complete stop. What happened, okay, that one went with D. What happened in this one? Did it start from a complete stop? Did the graph start? Was the car already moving? Did it already have a speed established? It did, didn't it? Because it's up higher. So how would it, what do you think? How would it be different? It would start at 0, and 0 on the coordinate plane is where?
In the center.
And where the two axes cross would be down here, wouldn't it? So instead of it starting up here where there's maybe a speed of, who knows, 30 miles an hour, I don't know what it started at, it would start down here and it would go slowly and steadily. I got it a little bit more sharply, but it would just start at the origin instead. So we can say that in words. It would start at the origin. Okay? But its speed isn't going to change. I mean, how fast, the speed is still going to increase slowly and steadily. So in reality, I'm just going to erase that because that is not a good representation of what I just said. It should go like this. Okay? So it just starts at a different spot on the graph. Because the y-axis is representing speed. There was no speed at the beginning. It was started from a complete stop. Okay, discuss what it means for the graph of the car's speed to be a horizontal line. It's doing what, Michaela? It stays the same, yeah. The speed is staying the same. In fact, there was a situation, let's write that, the speed, and by the way, we're writing, what do you suppose I'm going to say? Sentences, they start with capital letters, they end with punctuation. The speed would stay the same. Well, not be, that doesn't make sense. This speed would, didn't need the word be in there. Or in other words, it would be, the speed would stay constant. If they were driving 40 miles an hour, they'd stay at 40 miles an hour. What keeps you at 40 miles an hour if you want to make sure that you stay at a constant speed in the car? Cody? Cruise control. But in our car, of course, we don't use cruise control much in the winter because we could hit black ice, right? Okay. So here's somebody with cruise control on in graph C. I can't drive without cruise control on if I want to keep it at a steady speed for some reason. Okay, I want you to go to page 164, and we're going to do check it out. And I want you to flip your papers over to the back side. And at the top, I want you to put, first I want you to put this, check it out. Write those words, check it out. And we're going to do the one, it's at the bottom of page 164. So put check it out, page 164. I really want to start a new page. I just wanted to add a page here. Okay. should know how to do that. Okay, so we're putting on here that we're doing, check it out. Page 164. And I'm gonna count on you to read through this lesson on your own and get the information that you need to make sure you learn how to do this stuff well. But we're gonna do this one together where we are now going to do our second objective today. It says, I can graph a relationship. So, anybody want to read for us out loud? Okay, it's Jessie.
The air temperature increased steadily for several hours and then remained constant. At the end of the day, the temperature increased slightly again before dropping sharply. Choose the graph above that best represents the situation.
Oh, we get to choose from graphs up there. We're going to reproduce that graph on here as we talk through it and see if we can make sense from it, okay? So because apparently this, if we would have read through example 1, it's about the same sort of thing, air temperature. So notice, let's do this first of all. What's on the x-axis? So what title are we going to give the x-axis? Temperature or time? This one is time. Typically we just do, and I think that's what they did in the book too. Typically we put the time on the x-axis because time kind of controls things, okay? And then we're going to put the temperature on the y-axis. So when we're graphing, we always want to be able to tell ourselves and anyone else who looks at that graph how to make sense of it, how to read it. So we have the temperature on the y-axis, the time on the x-axis, and we're going to, instead of going up and picking one of those graphs, we're going to do this ourselves and see if we can figure out which one it matches to, okay? So the air temperature increased steadily for several hours and then remained constant. So the air temperature increased steadily and then remained constant. Okay, so increased steadily, what would that look like? Jossie, what would increased steadily look like?
Starting the origin.
Okay, so you want to start from the origin, okay, and increase steadily, so then what would it do? Okay, and
Sharply.
does it say increased sharply or just says for several hours, right?
Yeah, well, going up.
Okay, so it increased for several hours, okay, so we'll just, assume that's a good indication of several hours. It increased steadily for several hours, and then it says remained constant. What would that look like? A horizontal line segment next. So then we're going to draw a horizontal line segment. Remained constant. So here's our, let's put this in our notes here. Increased steadily. That's that part. That's those words. That's taking the situation and from the wording deciding how the graph should match that. This is remains constant. That's an O there. And then what does it say next? It says, at the end of the day, the temperature increased slightly again before dropping sharply. But did they say steadily? No, they just said increased slightly. So what would that look like? Yeah, kind of like it's going, it's going up, but then it also says slightly again before dropping sharply. Okay, so it's kind of like it's going up and it's not saying steadily, so when it's not saying steadily, we don't necessarily need it to be straight. Okay, so it's increasing steadily before dropping off at the end of the day. So now let's maybe we should do this part first though. So increasing, what was the word they used? Slightly. So increasing slightly before dropping sharply. So now it's going to go down pretty quickly, right? So decreasing sharply. So now go to those graphs, graph A, graph B, graph C, and let's decide which one does it appear to be closest to. C? Match that one? Okay, so we're going to say graph C. So when you're doing these in your homework, I expect you to put this much thought into them. I don't want you to just, oh, I just need some pencil marks on the page to look like I did my homework. And I say to you tomorrow when you come, you know what, that's not enough effort for me, sorry. That's what we did yesterday in class. So anybody have any questions on that one? Okay, we're moving on. We're gonna do now page 165, so will you make that note? Hopefully you didn't use the whole side, because we got 3 problems we're gonna do. So that should have hopefully only taken you at most maybe a third of your paper. So we're going to do page 165, check it out. And we're going to do, actually we're only going to do 2 problems, but this one has 2 parts, so that's how we get 3, we need 3 places. So 2A, page 165. Sketch a graph for each situation, tell whether the graph is continuous or discrete. Well, it looks like we better figure out what continuous and discrete is before we go on to doing this. Let's go all the way to the top of the page. It says, as seen in example 1, some graphs are connected lines or curves called continuous graphs. So we just drew in number 1 a continuous graph. Some graphs are only distinct points, or in other words, we do not connect the points, we just have points on the graph to show the situation. These are called discrete graphs. So they show an example of a discrete graph right below that. There's that theme park attendance one. So the number of years, the number of people. So they did not connect the dots because the information they're trying to show there is how many people were there in a certain given year. Okay? So there's no continuous stuff going on. So let's go down to 2A. Jamie is taking an 8-week keyboarding class. At the end of each week, she takes a test to find the number of words she can type per minute. Have you guys ever had to do this? Yeah, I think so. She improves each week. Okay, we need to draw a graph for that and decide if it's continuous or discrete. Well, I think we better decide if it's discrete or continuous first, so we know whether we should draw connected lines like we did just now, or we should just have points. What do you think? At the end of each week, she takes a test to show how many words she can type per minute. And how many weeks did she take this class for? 8. So what do you think? Do you think we would draw continuous lines for this, or would we just put distinct points on the graph? Yeah, we just put distinct points showing her test score after the first week, her test score after the second week, 3rd, 4th, 5th, 6th, 7th, and 8th, and we would not connect them. So this is actually going to be a discrete one. So let's just say, you know what, we better draw it discrete. First of all, it's a discrete graph. I think sometimes that's the decision you need to make first, and then go about graphing it. So let's get up our coordinate plane setup. We are only using quadrant 1. And that's what we used last time also. We're going to put weeks, the number of weeks, let's put those on the x-axis. And let's put the words per minute on the y-axis. Okay? So the number of weeks and the words per minute on the, and we need 8 weeks. So I think what we should do is we should put 8 tick marks. So we can 1, 2, 3, 4, 5, 6, 7, 8. So we can kind of have some sort of, something to follow. Because what did it say her test scores did? They increased. Did they use any other words? At the end of each week, she takes a test. She improves each week. So, does she have to improve the same amount every week? No, but every point should do what? At least get higher, go up, right? Okay, so let's just start here. Let's say, you know what? Oh, there's her first score. We don't know, or words per minute. We don't know how many words those were. We don't even really care. All we know is that she improves every week. So now when we make our next point, we have to be higher than that one. She improves again, so it's got to be higher than that one. Do they have to go in a straight line? Not necessarily, but they need to show improvement every single week. So they always have to keep getting higher. And make sure you have 8 points on your graph, because I don't yet. So she improves every week. So the points one can't ever be lower than another. And we have our graph. So questions on that one? Okay, let's do 2B now. 2B. Read the situation to yourself and decide, do you think that would be a continuous or a discrete? What do you think? How do you feel about that? Do you think this one's going to be discrete or continuous? I think this one would be continuous, right? Okay, so let's do that. We're going to say, you know what? We're going to try to make this a continuous graph. That's what we believe it should be. And then we got to decide what are the two things that have a relationship here. So what are the two things that are going on? He's opening different valves. So what's happening as he's opening these valves? Are we going to be graphing him opening the valves, or what are we going to be graphing? The water level, right? What the water level is, because won't the water level change? So let's make the water level our y-axis. Water level. And then what else is going on? Here's what typically goes on in a continuous graph. Time. Is that what you think we could put? Okay, because he says he begins, then he opens, then he closes, then he leaves. Sounds to me like time's got to pass. So let's put time on the x-axis. Okay. So he opens the first valve. What do you suppose the water level is then? Probably high. It's probably got a lot of water in it at that point, right? Okay, so we're going to start up here. And then it says he begins to drain the water. So at this point it's starting to drain out, right? Okay. Then he opens another valve, and it doesn't say that he closed the other one. Oh, it says he opens another valve, but then he closes the next valve. So we got to first of all show that he opens another valve, and then he leaves that second valve open until the tank is empty. So he's opening another valve, but he's not closing the other one at the same time. So what's going to happen? How fast is it going to drain out? Faster, slower, same pace?
Faster.
They better drain it at a faster pace. So now all of a sudden we got to make that sharper. We got to say, oh, there's that. There's two valves open right now. It's draining out faster. The water level's going down faster. But then he does close that first valve, and now the other one, and it finishes out. So now it's going out slower again, isn't it? Okay. So this is how these are the kinds of things you're going to be doing in your homework today. Being able to match graphs with situations, being able to draw graphs for situations, relationships.